Hello all, welcome back to my channel. So in this video we'll discuss some objective questions related to fluid properties. I hope this video would be helpful for people who are preparing for competitive exams and even for computer based exams. I would be concentrating on basics related to fluid properties. Okay, so let's see the question number one. So first question is, fluid is a substance that. So this question is about the definition of a fluid. So fluid is that substance which cannot stay at rest position when it is subjected to any shear force. Okay. So a fluid can be both a liquid as well as a gas. In either of the cases, when there is any external force applied, the fluid cannot stay at rest. That's called as a fluid. And according to this question, our option number 3 would perfectly suit, and hence option number 3 is the correct answer. Second one, fluid statics deals with fluids. Okay, so fluid statics is fluid mechanics. See, I'll just show you a small flow chart. So actually, fluid mechanics is broadly classified into two types. One is fluid statics and the next one is fluid dynamics. So the fluids when are at rest position, you call it fluid statics. Okay, this is when when the fluid is at rest, and when the fluid is in motion, we call it fluid dynamics. Further, fluid dynamics is classified into two types: fluid kinetics and fluid kinematics. In fluid kinetics, we consider the force causing the motion. Okay, means when the fluid is moving, there will be some force which is making it to move, right? So that is called as kinetics. Whereas in kinematics, we just talk about the fluid in motion, but we do not consider the force. Means we say that the fluid is moving from section 1 to 2, but we are not concerned about the force which is making the fluid to move. Whereas in kinetics, we say that a fluid is moving from section 1 to 2 under gravity or due to pressure, like that. So, according to this question, fluid statics deals with fluids at rest. So, third question, fluid kinematics deals with fluids in motion. Just now I told you, fluid kinematics means yes, it is a part of dynamics which deals with motion of fluids. That is the first thing we have to get into our mind. But whether it is with consideration of force or without consideration of force is what you need to remember. In fluid kinematics, we do not consider the forces. So this is without consideration. Right. Fourth question. Fluid kinetics deals with fluids in motion with consideration of forces. Next, density of a fluid is defined as. So density of a fluid is generally denoted by the symbol rho, Greek symbol rho, and it is defined as the ratio of mass of fluid to volume of the fluid. And the units of density in SI system are kg per meter cube. This is in SI system. If you're talking about units in CG system, it is gram per centimeter. Next, density of water. So as I've told you, fluids are both liquids and gases. This is what I have told you. So in liquids, we consider the standard liquid to be water, and in gases, we consider the standard gas to be air. Okay, these are our references. So you need to remember some important values. And in case of liquids, you need to remember the values related to water and mercury because they are the most combinations used. And coming to density of water, this is a standard value. Density of water is 1000 kg per meter cube. Next, specific weight is the product of. So just now we discussed density was mass of the fluid to volume of the fluid. So generally, specific weight is defined as weight of the fluid to volume of the fluid. This specific weight is also called as weight density. When mass density is mass by volume, weight density will be weight by volume. So weight can be written as product of mass into gravity by volume. This m by v is what? Rho. So this can be written as rho into g. Hence, specific weight is the product of density and acceleration due to gravity. Specific weight of water in SI units is equal to, just now we discussed density of water is 1000 kg per meter cube, and just in the earlier slide we have discussed formula for specific weight as rho into g. So from here what can we get specific weight of water? 1000 into 9.81, which comes out to be 9810 Newton per meter cube. So the fourth option is the correct answer. Next, question number 9. Standard fluid in case of liquids is, just now I told you water is the standard liquid or standard fluid in case of liquids, whereas for gases it is air. The question is same. Standard fluid in case of gases obviously air. Next, specific gravity of water is. So generally specific gravity is denoted is defined as density of the fluid to density of standard fluid, which is water. Here already I am calculating specific gravity of water only. So it is 1000 by 1000, which is equal to 1. And remember, specific gravity doesn't have any units. It is dimensionless quantity because it is density of fluid by density of standard fluid. Next, specific gravity of mercury is 13.6. This is another important value you need to remember, because we will be using this value in manometers. Next, 1 liter of crude oil weighs 9.6 Newton. What is its specific gravity? So here in this question, 1 liter of crude oil is given. 1 liter means volume is given to us. Volume is 1 liter. Okay. So 1 liter means it is 1 by 1000 meter cube, because we have a conversion 1 meter cube is equal to 1000 liters. So from here 1 liter is 1 by 1000 meter cube. And oil is weighing 9.6 newtons means weight of the oil is given, which is 9.6 Newton. He is asking us to calculate the specific gravity. So what is specific gravity formula? Specific gravity is density of the fluid by density of standard fluid, which is water. So if I am able to get the value of density of the fluid, means density of the oil here, in this case I can get the value of S. So how would I get the value of density of oil? So for this, just now we have discussed a formula. Specific weight is equal to weight by volume. Let's see if we can apply this formula. So specific weight is weight by volume. Yes, from here you can get the value of specific weight. So from here this is equal to 9.6 by 1 by 1000. So finally our specific weight is 9.6 into 1000. Okay. Now once you get the specific weight, what you can do? You can calculate. We discussed another formula for specific weight as specific weight equal to rho into g. So from here what is rho equal to? Specific weight by g. So rho will be equal to 9.6 into 1000 by 9.81. So from here you'll get the value of rho. So once you get rho, you can calculate specific gravity. So specific gravity will be this rho by 1000. So I'll solve and tell you the answer. So this answer came out to be 978.59 kg per meter cube, and hence specific gravity will be 978.59 by 1000. So the answer is 0.978. Next, the property of fluid by virtue of which it resists movement is called viscosity. Viscosity is the property of the fluid in which one layer of the fluid exerts a resisting force on the other layer, thereby causing the entire resistance to fluid movement. Next, dynamic viscosity. See, dynamic viscosity is denoted by the symbol mu, which is nothing but the ratio of shear stress to shear strain. So shear stress is denoted by the symbol tau. Shear strain is given by du by dy. Shear strain is also called as velocity gradient, and this is obtained from this formula. Tau is equal to u into du by dy. Okay, so hence dynamic viscosity is defined as ratio of shear stress to shear strain. So option 3 is correct. According to Newton's law of viscosity, shear stress on a layer of a fluid is dash to the rate of shear strain. So shear stress is directly proportional to shear strain according to Newton's law of viscosity. So from here, if we remove the proportionality constant, it is becoming mu into du by dy. And just now we have seen the formula for mu. So hence shear stress is always directly proportional to shear strain. So option 1 is correct. Next, choose the correct relationship. We have another viscosity which is called kinematic viscosity, which is denoted by the symbol nu, which is the ratio of dynamic viscosity to density of the fluid. Okay, so kinematic viscosity is the ratio of dynamic viscosity to density. Let's see if this relation is available. So here only we have one option, which is kinematic viscosity equal to dynamic viscosity into density, which is wrong. It should be by. So from here we will see what is dynamic viscosity equal to kinematic viscosity into density. So option 3 is satisfied. Next, poise is a unit of. So just now we discussed dynamic viscosity is denoted by the symbol mu. This mu has the units of Pascal second, okay, which is Newton second. Okay, so sorry, Newton per Pascal is Newton per meter square, right? So Newton per meter square into second. These are the units of dynamic viscosity. This is in MK system. It is kilogram force into second by meter square. This is in MKS. In CJ system, we can write dyne second per centimeter square. This dyne second per centimeter square is called as poise. Okay, and remember, 1 poise is 1 by 10 Newton second per meter square. So here they did not ask conversion, they asked poise is a unit of which quantity? It is dynamic viscosity. So stroke is a unit of. Similarly, we have just now seen kinematic viscosity, which is the ratio of dynamic viscosity to density of the fluid. So kinematic viscosity units are meter square per second in SI system and MKS both. For CGS, it would be centimeter square per second. This centimeter square per second in CGS system itself is called as stroke. Okay, and remember, 1 stroke is equal to 10 power minus 4 meter square per second. So it is a unit of kinematic viscosity. Poise is for dynamic viscosity, stroke is for kinematic viscosity. Next, mercury does not wet glass. This is due to property of liquid which is known as surface tension. Next, surface tension as the units of. So surface tension is a tensile force acting per unit length. So you can say it is either force acting per unit length, or also you can say it is energy acting per unit area. So if it is in terms of force and length, it is force per unit length. So the units of surface tension would go with Newton per meter. So this is the correct answer. Next, a fluid which is having no viscosity or which is inviscid in nature is called as. So based on viscosity property, we have 5 types of fluids. We have real fluid, ideal fluid, Newtonian fluid, non-Newtonian fluid, and ideal plastic fluid. So these 5 types of fluids are specially classified based on the property of viscosity. Okay, and among this, the fluid which is not at all having any viscosity is called as ideal fluid. But remember, ideal fluids are imaginary. Every fluid whichever is existing on this universe will have viscosity. Next, a fluid which is having viscosity is called obviously a real fluid. So every fluid in this nature is real, but only for imagination purpose we imagine the fluid to be ideal in nature, so that no losses would occur. Next, a fluid whose rate of shear stress is directly proportional to rate of shear strain. Rate of shear stress is tau and rate of shear strain is du by dy. So if the fluid in which tau is directly proportional to du by dy, this tau directly proportional to du by dy is also called Newton's law of viscosity. So that fluid which obeys Newton's law of viscosity is called as Newtonian fluid. And a fluid which doesn't obey Newton's law of viscosity means indirectly a fluid in which shear stress is not proportional to shear strain. Then it is called as non-Newtonian fluid. Okay. Next, vapor pressure. Vapor pressure is closely related to. So what is vapor pressure? Now imagine there is a bowl which is consisting of some water and we provided heat from below. So now slowly after the boiling point is reached, the water starts boiling. So we have closed the vessel with a lid. So since we are giving temperature from below and water started boiling and vaporization takes place, so slowly the liquid state is changed into vapor state. But since the vapor molecules cannot escape outside, since we have closed it with a lid, what happens? The vapor molecules will get stagnated here. So these vapor molecules will try to exert force on the existing surface of water, which is called as vapor pressure. And vapor pressure is especially related to molecular activity and temperature, because we are giving heat from below, so there is temperature and molecular activity. We have the movement of molecules. Next, which of the following machines have the possibility of cavitation? So cavitation is generally occurs when there is a sudden change in the pressure region, and mainly cavitation occurs in reaction turbines and also in centrifugal pumps. In impulse turbine, there is no chance of formation of cavitation because the water strikes and only we are considering the kinetic energy. So there is no possibility in impulse turbines and reciprocating pumps. Obviously, it acts in reaction turbines because for reaction turbines we have a casing, and when the water is traveling through the casing and later falling on the runner, we have a chance of pressure difference created, and hence cavitation can occur both in reaction turbines and centrifugal pumps. Centrifugal pumps are just the reverse of reaction turbines. So in both of these cases, we have cavitation possibility. Next, liquids, for liquid fluids, will capillary rise or fall, increase or decrease with rise in temperature? So remember one thing, viscosity for liquids. So we have two. We have liquids and gases. Right, we have the formula for capillary rise or capillary fall as H is equal to 4 sigma cos theta by rho GD. So here, as the temperature increases, surface tension will decrease. So surface tension is in the numerator. So hence when surface tension will decrease, obviously your capillarity also will decrease. Which one of the following is the correct relationship between compressibility beta and bulk modulus K? So the relation between compressibility and bulk modulus is both of them are inversely proportional or inverse of each other. So second one is the correct answer. About the basics of fluid properties. I hope I was able to cover all the fluid properties. If anything is missing, please let me know in the comment box. Thanks for watching.